right, our friend number 6. This one has a lot of numbers thrown around. Take a moment, please read the question, and then we'll go through it. All right, so in simple terms, even though we can't see it here because it's a static picture, what we're saying is that this thing is going to undergo simple harmonic motion between -3 and -0.3 and 3. What's important is that it's asking for the magnitude of the acceleration and at this position right here. So if we want to imagine the spring being stretched out a little bit more and the block being here, it's asking what is the acceleration at this point. Now we know that it's going to accelerate to the left. We also know that we're going to use F equals kx. That's Hooke's law. Now it asks for the magnitude, so I'm just going to leave off the negative sign. And importantly, we also know a basic fact, which is that F equals ma. So on this side we can say ma, that's the force. And on this side we can say kx. Take a moment, see if you can find the answer from there. So once you realize that you need to set Newton's second law, F equals ma equal to kx, it's pretty straightforward from there. It wants us to find the magnitude of the acceleration and, oh yes, the direction of the net force. We'll get to that in just a moment. So all you do is solve this for a, divide both sides by m, and you get this. Plug everybody in, and you get 30 meters per second squared. So let's look at the answer choices and pick a sensible one. Again, we got 30 meters per second squared as our answer. So it wants us to get the magnitude of the acceleration. Okay, this is great. We can already eliminate C and D because the accelerations are wrong. And then we need to choose between positive net force direction and negative net force direction. Now, because it was displaced to the right, you can see hopefully here that the restoring force is going to act to the left. That's going to be our restoring force. Remember, restoring forces just push things back toward equilibrium. So it looks like it's to the left. Or negative in this case. Yes. So we displaced it to the right. The force is to the left. This thing here, again, you can think Hooke's law, the real thing. F equals minus kx. Since we have a positive displacement, the overall net force is going to be negative. That's it for number 6, folks. Not too bad.